Hello and welcome to the first of Norhybrid webinar entitled No Power, No Problem, Build Energy Resilience for Your Business. I am Carl Ivar Holmen, CEO of Norhybrid.
And I'm Trond Sørensen, heading up sales and marketing.
We're excited to be here today. I'm going to tell you a little practical information to start. So we will share this recording and presentation afterwards. Save your questions towards the end. You're welcome to leave comments or questions in the comments field, and we'll get to it in the Q&A session at the end of this webinar. Okay, so to start with the overall Norhybrid system and the concept that we are working on, we work in the distributed energy domain. So what that means is that we produce power where it is consumed. So today you have solar systems that do that. We introduced the wind component to that through our proprietary vertical axis wind turbine, the Energy Blade 3.7. By combining these two energy sources, the solar and wind, you get what's called complementarity, meaning that you can have energy produced year-round on your location. This is important because it's not just energy needed in the summer. Energy is needed year-round, and typically energy prices are higher in the winter, consumption is higher, and there are few viable alternatives for this type of energy, local energy production, other than wind, and we have the technology for that. So the purpose of this webinar is to really understand the acquisition process, give you an idea as a prospective buyer how this works, and we have a step-by-step breakdown that we are going to be going through today. The first step is a site assessment. The second step is understanding the business goals, so what is the motivation for this type of investment. The third step is how to actually get a proposal from us and from our partners. And step four is really what happens after the purchase and how the approval process goes with the municipality and how to schedule installation, and also some information about regular maintenance needed in the years of service. So, Trond, do you want to take us to the site assessment on step one?
Yeah, absolutely. I mean, the key thing to do is to get an idea of the wind conditions. That, step number one. And we have built a tool called WindSat. It's a wind site assessment tool where we produce reports similar to what you see on the screen here today. The point of this is then to allow the customer to have an idea of how much energy would our wind turbine produce on that location. So if you like, I can maybe do a demo to see how it works.
Yeah, why don't you do that? Give us a demo.
Okay, let me just switch out here. And then, yeah, so this is the tool. We can do a webinar test here. And on a given location, hang on a minute. I need to just quickly go and get my address here. Sorry about that. So we put in the address quickly, a little bit like this, and then we can press estimate. What happens now is we use public domain historic wind data to see on this site how much wind is there. We can here see, I can enlarge this a little bit. So it's 9.1 meters per second average wind on this location. So that's very good wind. And that means also we would have high results up to 12,500 kilowatt hours. But you see here there's a low, so there's a range on this site, and the reason is that we're mapping out a 1 kilometer by 1 kilometer area. That's the granulation we have access to. It means depending on where on this square you place the turbine, you would see different results. So always we look for with the fewest obstacles and buildings and things in the way, so that there's as much free wind as possible.
What are these values that you have up here in the right-hand corner? The wash machine, and the
Yeah.
CO2 offset?
Yeah, it's to give an idea of equivalent. So what would this mean? So if we take the 12,500, which is the highest here, that would give you, 10,000 wash machine cycles per year. So you can run a small business, cleaning business for that. You can drive over 100,000 kilometers with an EV, electric vehicle. And on the lifetime of the turbine, which is 20 years plus, the offset is 235 tons of CO2 that you would offset using a turbine like this.
Okay, interesting. Can you scroll down a little bit? There are a couple of other important aspects of this. We have the windrows, and you see here is a dominant wind direction. And I guess this is important then to ensure that you, when you do the site assessment, that you don't place the turbine behind the building, which is in the dominant wind direction, correct?
Yeah. That's one part of it. The other part is that if you set up several turbines, you can actually get a cluster effect. So if you set up a turbine in a kind of triangle, there are 3 turbines in a triangle, the turbines behind actually have a positive contribution from the ones in the front. So that and this is something we do when we have a clear dominant wind direction, like we see here.
Right. So we actually have an increased system efficiency by placing the turbines close together in a predetermined pattern that we help the customer with.
Yeah, exactly.
All right, and then we have the table here. Explain this.
Yeah, so this graph shows the distribution through the year. This is quite typical to see in the at least northern hemisphere, that you have the highest bars and the most energy production in the winter months. During the summer, it's typically less. So this is a very classic curve for that.
And is this tool available and report available for anyone?
Yeah, so this is a tool that we use and our partners have access to, so they can run this. But we also have a light version available on our website. So where we can do the similar exercise that we just did. Anyone can go to this site and just put in their address. I'm going to use the same one we just used, and press estimate. And that's the same tool that is then deployed and used for calculation. You see here the 9.1 meters per second, same, and also the expected output. You can also, if you want to have, simulate, if you have, 50,000 kilowatt hours consumption every year, you see here that, increasing that to 4 turbines will basically take you there. And it also updates then the EV, the washing machine cycles, and the CO2 offset.
That's great. So, and how would you, as a potential customer who is interested in a wind turbine and does this light assessment of the conditions, how do they get more information? How do they get a hold of us or a partner?
Yeah, the easiest way is just then to submit this to input your information, your name, email, phone number, etc. And then just press yes, please send me the report, and we will then reach out with the full report like we saw earlier, and having then we'll reach out to the customer and include the most relevant partner from that covers that market. So that's a pretty straightforward process there.
Great. This is a pretty good segue to step 2, which is understanding the business goals. So what drives the motivation to invest in a wind turbine, to invest in a hybrid system? Do you want to tell us a little bit more about that, Trond?
Yes. So when we look at a solution for a customer, we try to understand the motivation for the customer. Is this, primarily to reduce the energy cost? Is it the to be more resilient from the grid? We had just a couple of weeks ago, all of Spain, part of Portugal, and France had outage of over 10 to 12 hours. So, or is it more from a CO2 offset perspective that the company or the customer wants to offset their CO2 footprint? So this is all important for us to understand, and also what is the energy consumption. So what are we looking at here to reach? What's the goal from the customer's perspective to replace? So those two are kind of important parameters in addition to kind of the wind that we started.
Sure. And then we see, of course, when we work with clients that a number of them are considering solar installations, or they already have solar installations, and their motivation then is to ensure you get power year round, right? Because solar typically will provide you with energy 15 to 20% of the time. While if you introduce the wind component, provided that you do have good wind, you actually get energy around the clock all through the year, correct?
Yeah, and especially kind of if you introduce a battery as well, you can even out the kind of outage periods where there is no no sun or no wind. But so this is the image you see here on the screen is kind of how we think about the hybrid systems to include both solar and wind, and also if required, a battery for the overall solution and reduce outage times to a minimum.
Just to expand a little bit on that. So, of course, some of our customers are bigger and have ESG reporting requirements. We'll get back to one of our clients who has an overall, should I say, pretty comprehensive sustainability strategy. But for some, it's also this increase in the local production. I mean, how much can you really see in terms of increase in production of local energy? If you think from solar, which is 15 to 20%, are we talking up to 100% local energy produced, or?
Probably not, but you can reach very high percentages, and that depends a little bit. And the combination here of solar and wind allow you to play with this a little bit. So let me show you an example from the location we just looked up at with WindSat. This was a specific need to have a relatively even curve of consumption through the year. So they doesn't matter whether it's summer or winter, they use pretty much the same every month. And what you're seeing here is on the bottom left, you will see the typical solar curve for that anyone that has solar panels already experienced. Summer months are great, but winter months deliver very little. The next one over, the green curve, shows the wind distribution we saw earlier, right, where you have the most production of wind from wind in the winter months. And this specific configuration had 84 solar panels. They had 4 turbines, and even if the installed effect of solar was almost or over twice the installed effect of wind turbines, you see in the bottom left curves that it's more energy delivered from the wind than from solar. And on the bottom right curve here, graph here, you see how these stack up on top of each other. Where in January and February you would have very little solar, you have the most produced wind energy. and as a combination of these two, it evens out pretty well over the year.
Yeah, and this is really the core of our value proposition for the customers. This optimization against consumption, and also the comparative benefits of combining the two.
Yeah.
Okay. Well, great. Should we move on to step 3? So, requesting a proposal. What is the process here?
So, like we talked about earlier, you can contact us through our website or email or any of our social media platforms. And that will allow us to then do an assessment of your wind conditions and kind of get the ball rolling. Furthermore, we will then put you in contact with our partner, local partner. We are a Norwegian company, so we can do in Norway. We can handle the request directly ourselves, but for any other market, we will use local partners. And they are already in renewable. They understand kind of maybe have solar installations. They have heat pumps, whatever is the additional products they have, and then want to have then added wind to their portfolio. And they will help build and configure an optimal solution for the end customer. And using the tools that we can provide and the knowledge they have from before, that will be kind of the initial step of creating an energy solution for that customer.
Right. And so just to think about this in terms of how well a hybrid solution can actually match your consumption profile. Because if you want to try and do the same with the solar only, you are going to have to over-dimension your solar installation, meaning that you have a lot of extra production that you need to get rid of somehow in the summer, right? So you're either talking curtailment of that production, or you are selling it in the market when everyone else is selling solar energy at very low prices. So optimizing. So in some cases, actually, what we do is we recommend for the customer who wants a hybrid solution to reduce their solar installation, make sure that they combine with our wind turbines to get maximum yield locally, to send as little as possible onto the grid and use all of it locally.
Yep.
All right. So how quickly can you produce a proposal? What does it include for a typical customer?
No, I think that as long as we understand the size of the consumption, the energy consumption, and we have the wind on the site, we can use then standard tools for solar and configure kind of the optimal solution for the customer. And that usually is done within a few days to a week sort of thing, to get all the details in place and maybe have a bit of back and forth with the customer of what this looks like and what would be then an estimated cost for this.
Sure.
And then the next step is then kind of to agree on the overall proposal. And you will also get guiding on local permit rules. In some markets, there is no permits necessary, but in most markets there are. Which is then typically a permit application to the local authorities. And again, our partners are well versed in that and would know how to set this up. And we will also be able to contribute with documentation necessary, and all of those things.
Sure. Yeah, so that was my next question. So what about soft funding, tax credits? How does this work in the different markets?
No, that's again, depending on the country's regulations, if they have incentive arrangements at all. Many markets do, some do not, and that's an opportunity there to get some soft funding or contribution for renewable energy installations. But that would be something that is discussed with the partner, who again have kind of the local knowledge and know what to do and what are the options here.
Right. And then do we provide, or obviously we do, but can you tell me a little bit about the documentation that we provide? So for installers. So we'll get into more of the details in step 4, but I'm thinking that we provide, of course, the turbine. Does it come as a kit? Is everything included, or tell me more about that?
Yeah. So in the proposal, one thing is the equipment itself that comes from us. That's the turbine, it's the mast, and it's the controller. So those 3 things are part of this. The additional things to consider is then the foundation. How do we fix this to the ground? And we typically have a couple of options there. One is shallow concrete foundation, which is armed concrete, 2.5 by 2.5 meters, 40 centimeters deep. Or you can actually drill down in bedrock, and you then have 2.5 meters down, and you more or less glue these to the rock, and that is sufficient foundation.
Great, and we'll see some examples of this in a little while. So I guess we're moving into the last and final step, which is what we call the prove and schedule installation. So so let's assume that we've convinced the buyer that they want to buy a turbine from either us or directly from our partner. They've discussed found the site, suitable site. They've assessed the type of foundation that's needed. They got the permit. Everything is placed. Now, what happens once the buyer actually gets the green light?
So the key thing is, so once the application is approved and the foundation can start being built, and I can show you a picture of a couple of foundations here that we've done. These are from UK. So here is on the left-hand side is 3 3 foundations. That's the shallow concrete slabs I talked about, ready done and ready for the turbines to be installed on top. On the right-hand side is another installation where we use where the concrete isn't poured in yet, so you see just the iron and the arming that's the cage that is basically there to then have concrete poured over it, and you see there's a ditch then going all the way over to the building in the background for the wiring.
Sure. And then just to comment on this installation picture here, Trond, because you see on the left-hand side, the foundation for those 3 turbines, first of all, they're placed in a particular pattern, but and this is to really exploit this dominant wind direction and the system efficiency increase that we see. But secondly, I guess just as interesting is that how tightly you can place these turbines. If you look on that location, you're actually putting 3 turbines on essentially two parking lots for cars. It's very narrow. So explain that.
Yeah, no, that's I jokingly say that we have our turbines are very social. They like to be put together, and it's really just 9-10 meters center to center between these turbines, and that's to like you mentioned, exploit the cluster effect, as we call it, to get more system efficiency out of it. And it also is good for that you don't occupy a lot of land for the energy production, and the land in between here can be utilized. This is not requiring to be boxed off or anything like that.
Right, and there's no need for cordoning off the area around, because the turbines are what's installed height about? It's about.
Yeah, so the mast itself is about 8 meters, and then you have on top of that is the turbine, which is 3.5. So roughly, just short of 12 meters total height here.
And noise levels are around?
Yeah, that's 36
39.
decibel.
Yeah.
39 decibel. Sorry, I confused myself. 39 decibel, which is like a quiet dishwasher from the turbines themselves.
So, in other words, it means they can be placed very close to where people work, where they live, which is the whole point of distributed energy, right? So, and you see in this installation here, it is basically in someone's backyard. They have a wind turbine. This is not something that you would see with a conventional big propeller turbine, where they require movement to be moved further away from building. We actually put them right where people live. So it's a pretty neat feature. Okay, so we, as you said, we can provide turnkey services for installations here in Norway, and then in other countries we work through our partners who also provide turnkey services. Yes.
Yeah, correct. And that is, take the customer through the whole process, have the necessary skills and experience to guide on everything from the configuration to the permit process to the actual installation and finally commissioning. So we make sure that the customer is followed through every step of the way here.
Great. And what about maintenance? Once installation, you have commissioning, customer's happy, it's producing energy, and then you have a lifetime. How often do you have to do maintenance, and what does that entail?
So it's actually relative or very very little maintenance needed, and that was one of the design goals when we designed the turbines. There is no gearbox here. There's no oil. All of this is as simplified as possible and made as efficient as possible. So basically, the maintenance needed is the ball bearings that needs greasing every 3rd to 5th year. So that means that depending if it's a lot of wind, every 3rd year. If it's little wind, every 5 year necessary. And that would be something that either the partner can do, or if you are sufficiently keen to do this yourself, it's also possible to do on its own. So it's very straightforward and limited maintenance needed.
Mm-hmm. Do you have any? We have installations now. We have thousands of hours of running time. Can you say a little bit about our experience with impact on bird wildlife?
Yeah, no, absolutely. We have had, like you said, we had I think it's about 38,000 operational hours now on our turbine over the last couple of years. And that on the demo site we have in the south part of Norway. It's actually right next to a bird sanctuary, so we've plenty of opportunity to challenge this, but it's really not an issue at all. And the reason is pretty obvious. Birds don't fly into trees. They see them and they avoid their flight path. So when opposite of large wind turbines, where you have a blade coming down in 150 miles an hour, hitting the bird on his back because he can't see it. It just happens, right? So it's very different in that respect, and we've not had a single incident over these last 2 years. And we patrol this. We have people who patrol this daily. We also have video monitoring 24/7, allowing us to have good control over this, and there's not been a single incident yet. So very wildlife friendly, and is not impacting environment in that way.
No, that's great. And I think we just recently completed an installation. I think you're going to be showing a video of that. And I think this is also good example of how our technology blends in into the environment.
Yeah, absolutely. I mean, we'll show a video, but I'll just give you context before we do that. This is a company called ASKO in Norway. It's in the on the port of Farsund, or the harbor of Farsund. And they have already existing solar array and wanted to add wind turbines for the reasons that we have just covered. So they have 2 turbines for the moment, and we were over there to install and got this up and running. That's a few weeks back, and have now good production from there. So why don't we run that video, and we can then look at what this looks like.
Sounds great.
We're here at Farsund Harbor today to set up our first wind turbine and allowing us to supplement the existing solar panels here.
We've been working with this project, this energy project for our client, ASKO.
We are outside in our yard looking at the site where they are building 2 wind turbines to expand on our self-reliance on the clean energy.
We've been looking for wind turbines for the last 3 years, but the problem was that the technology was not ready for this kind of implementation.
This is work ongoing today and tomorrow, and we are very excited about this project.
My name is Jon Skjeborg. I'm representing the company Elmec, and we have been working here for Einar Øgrei in Farsund, the installation of the Norhybrid windmills.
The turbines are supposed to be part of a renewable power supply for the site here. This is now expanding on our existing solar panel array, spanning about 300 square meters of solar panels.
From Norhybrid, that's kind of the concept we're all about, combining wind and solar. Solar is great in the summer, not much in the winter. And for turbines, it's the opposite. So you have great production of energy from turbines during the winter months and can, during the summer months, rely on the solar panels. It's a great combination of what we call hybrid energy solutions.
The 2 turbines will each produce up to 5 kilowatts. And if this is a successful project, we're looking at coating the entire hill here with wind turbines. The wind turbines and the solar panels will power our lighting, heating in the warehouses and the dehumidifiers, and also to charge our electric forklifts and cars.
We have been working on this project for many, many years, and we're happy to see this project now being fulfilled.
It has been a very great project and gone smoothly. As you can see, now the turbines are up, so we are just doing the last connection.
I want to say thank you to our clients, ASKO, and everybody who's been working with us to make this happen. It's been a long process to make sure that all this technology with the solar panels and the wind turbines, and they actually work together. And we're very happy to make this green transition happen.
Beautiful, isn't it?
Yeah, that's a beautiful, beautiful video. Okay, so this concludes the 4-step run through regarding the site assessment, the business goals, the proposal, how to request a proposal, and of course the approval process and the scheduling, installation, and maintenance. So we have time for questions. We open up the floor for that. And of course, if we run out of time, we can follow up individually if time's run out. So, Trond, how long does the full process take from initial contact to installation?
Yeah, I mean, getting the configuration and all of that done is only a few days, so that's not a big deal. But typically, from start to end, you have to have permitting involved, and that delays it. Also, if there are funding applications and those type of things, that can delay. So it's a great variation. But I would say you have to minimum expect a couple of months, and it could be up to 6 months to get everything applied for, funded if necessary, if possible, and then get the installation completed.
Great. Let's see if there's another question there. How long time did it take the installation, the actual installation, I assume it means, in Farsund?
Yeah, I mean, it was done in steps. Foundations were drilled. You saw the rig on the video and all of that. So it was over a few months that installation took. But the actual to get the turbines assembled, the mast kind of lifted up there, and the turbines on top took less than a day for those two. We had scheduled 2 days, so we had a lot of time. But that was pretty amazing to see. So it's not a complicated thing to do, but of course you need here, you have the concrete that needs to be set. You have the electrician to laying the cable. So there are more steps than what I just described. But the turbines themselves were very, very quick, and we were very pleased with that installation.
Yeah, this installation in Farsund was also special because it was right on the edge of this cliff area that they wanted,
Yeah.
and so it required some extra long crane, etc.
Yeah, and not having height of fear. Not fear of heights.
That's right. All right, there's another question from Rory. Can the mast and turbine be painted to blend with the environment?
You can. It's up to you. They are. What I need to keep in mind is that if you for the blades, for example, they are facing a lot of wind, clearly. So you could have that it flakes off and have to be redone and brushed up a little bit, but over the years. But there's nothing stopping from kind of further painting the turbines and the mast. I will say though that when you look at this from a distance, they do blend in. They don't stand out like in the environment. So it isn't a eyesore like that. But it's absolutely possible if you want to.
I just make a short comment because I was there on the official opening in Farsund just a couple of days ago, and we had good wind. I think we had 16 or 17 meters per second, so there was good production. And really, the only noise that you hear is a low type of humming from the generator. There is no swooshing or flopping or whatever noise that you get from a conventional propeller. So it's actually it's very, very low, and it's not noticeable in really any way. Andre has a question. What's the minimum wind speed necessary to make the business case feasible?
Yeah, we say that to have good wind, you need 6.5 meters per second on average or more. And that would give you we looked at the case earlier today, was 12,000 kilowatt hours a year. That is on the high end of what we see. So I would say more realistically, you can see from if we're talking about 6.5 meters per second, that's from 5 to and then upwards to 10,000 kilowatt hours per turbine. So that's at least gives a little bit of frame for that.
We have installations in the lower range also, and then of course in the upper range. And the thing about wind is the production output is not linear, and it's very different from a solar installation, where you can easily calculate what the annual output is. So for wind, it's different, where you have 8 times the output if you double the wind speed. So wind really matters when it comes to wind turbines, and the type of wind and how the profile looks over the year. So that's why we do these comprehensive assessments. Really to understand what the location, what you can expect from your location. All right, what is the typical install cost?
Yeah, that depends on the location. Clearly, how far from the mains, your electrical mains, is this installation? So cabling, wiring, do you dig through a road? All those things that are variables here. But so I would recommend that we look at the site and start kind of planning that with our partners where necessary, to then give a concrete answer to those questions. It becomes it's too many variables to kind of do in general.
So I can follow up that with a question for you then, Trond, because what kind of return on investment can you expect? Is that also related to the wind speed then, and the amount of work needed?
Yeah. No, it's various big variation depending on the wind. Absolutely, like you say. But if we have good wind conditions, like we talked about, the 5 to 10,000 kilowatt hours per year, that could give you from in the low end maybe payback time of 7 years, maybe up to 10, depending. Again, it's very wind dependent. Yeah, hi.
Hi.
Good.
Great. Do we want to make another comment on any post-installation services that we do? Is there a software solution that comes with this?
Yeah, so you get the standard monitoring tools right out of the that comes with this. So you will have a web access to your turbines and to see how much they produce. Any alerts or warnings would come up there, but normally this would just be running in the background. You don't spend time on this on a daily basis unless you're an enthusiast. But it's
Sure.
But it's really kind of show you then historically how much has been produced, which months, and kind of those type of overviews that we provide. Long term, we're also looking at offering a energy management system, which is more can then take into consideration not only storage and those type of things that we looked at, but also do load control in your business, so that if you have loads that can be consumptions that can be disconnected for a while, or those type of things, they will be able to control through this system. But that's a little bit ahead of time, so I think that's more for a later in the year type of webinar.
Right. Yeah. Demand side management is very interesting. There's a question here from Leon. Can you say something about typical LCOE that you can reach at?
Yeah. So with the variations we just talked about, it will be depending on the local wind. But we have seen LCOEs there down to around 5 euro cent per kilowatt hour, and that is kind of gives you a little bit of an idea of what we aim for. So that's kind of just as an indication, at least.
Yeah. Okay. So if there are any other questions, we'll of course follow them up later individually. Again, the 4 simple steps now was the site assessment. It's key to do, really understand your conditions locally. Do you have a reason to put a wind turbine there, and where would be the best place to put it, and what kind of expected output can you get, and then how to build a business case around it, what motivates you as a buyer to invest in our technology, and of course then it's how do you get it, how do you get the proposal, and who do you work with from us? Is it us directly or our partners? And then finally, when you made the decisions, how do you move forward with the approval process and installation and the follow-up maintenance? So we have contact info, I believe, and you can contact us via our website, of course, to get a consultation to assess your site and to get more information from us. So we look forward to that, and thank you all for taking part in this webinar, and I look forward to talking to you when you are ordering your first wind turbine from us. Have a great day.
Thank you.